All right, looks like we are live. Good afternoon. This series will be the start of going through the Kaggle competition for the NFL Big Data Bowl. The idea here is that we predict the post-snap action based on what you're seeing pre-snap. It gives a little bit of an overview here. This is just copied directly from Kaggle, but at the end of a play, it begins by players switching out, going on and off the fields until they're back to the formation that they want. And then they go into the call where they're making their adjustments based on the formation. And then you could do a bunch of things like motion shifts, making changes, decide. So the idea there is that you uh, change your look and hopefully catch the opponent off guard. And then all this is prior to the snap. And then once the ball is snapped, then there's going to be what the play actually is. So then the goal here, and it's pretty open-ended, is to generate actionable, actionable, practical, and then novel insights based on the tracking data before the snap. And also, you want to look longer term at player and team tendencies. So it gives a few examples here of just kind of telling if it's a run or pass, what is, based on the scheme, what are they going to do, and then individual player predictions. So part of this is completely wide open. The idea here is that you have one of three tracks to go into. One we won't be able to do simply because we are not undergraduates. So that's out. The second track is to look at the metrics. So try and look at a team's or player's performance, and you can decide to focus however you want to do on that. So if you want to focus on offenses or defenses or anything, they say that generally you want to be more narrow rather than being kind of looking at this with a very wide lens. And then the third track is to do a presentation for the coaches. You're limited to about 20 slides for those, but the idea is that you will kind of put together a package for the coach, almost like a scouting report, and then present it basically to the coach or to the team with the presentation that you put together. The competition's already been going on for about a month now. There's about 2 months left. The deadline is shortly after the new year. And then they have a variety of scoring criteria. It's, I would say, fairly well balanced on 4 facets. The first is kind of the football side of things. So would you actually, like, would a team actually be able to make use of this? Are any of your ideas accounting for basically the intricacies of football? The other side is like the actual data science thing. So whatever you're saying, can you back that up with the data that you're using here? What are the models that you're using? Are they appropriate? And then any innovation that you would have here on the data science side. The last thing is, or sorry, the next thing is like how your report is actually written. Is everything like clearly defined, easy to follow? And then your visualization. So can you actually provide the, the code for that? Is everything accurate? And then another couple points here for innovation. And then it says it will be judged by actual members of NFL teams. And this is being sponsored by the NFL itself. So each set or each notebook has a slightly different requirement time. You're basically limited to 20 slides. You won't be necessarily showing the code in terms of your actual presentation. You'll want to be kind of more generalized version of it, so not necessarily technical in terms of explaining how exactly you did what you did, but being able to then turn that into understanding your audience and explaining it to people with an NFL background. So everything has to be ready by January 6th. So we've got about 8 weeks to get through this. And then the reason why this is interesting is that if you are selected as one of the winners, there are 5 different groups. There's 10 overall. You get a part of the prize pool, and then you will go to the NFL and do your presentation. And some of them will go in front of the team, some will go in front of the administrative team there. So overall, a very unique opportunity for these. So if you're really looking to get into data analytics and specifically into sports, this is a good runway to do this. Looking at the competition the past couple of years, some of them are really neat projects overall. And so let me share that out here because they had shared it in their forums as well. Share that there. It basically has all of the winning submissions from the previous years. And this is year 3 of the competition, but you'll kind of realize that, yeah, some of these are actually novel or using data to explain what they're doing. Last year was focused on not player interaction, but like player impact or movement data. So you could tell like if a player hit another player very hard, you would almost cause the opposing player to go backwards based on that. So you had to have a really good layout for how your players are interacting in the field of play. Another one was the year before that was just kind of more general. So trying to identify what the defense is going to do in relation to the offense. So more, this is more, or that's a more focused version of the competition, being focused purely on like the defense side of things. But now it's going, it's more general. So you have a lot of options here. You can focus on individual players, like I said, teams, offenses, defenses. I think an interesting look here is if we can find a way to create um, a larger analysis across the league and then look at specific ways that like individual teams are doing things really well compared to others. For example, looking at like last year's data in a similar situation, if we had this, would be the play that's called the tush push. It's made famous by the Philadelphia Eagles. They line up basically when they need less than 2 to 3 yards on the play with a very power-oriented formation. That means everyone's bunched in real tight. And the idea there is that the quarterback immediately takes the snap and drives forward, and then has players behind him to also help him to push in there. And other teams had tried to run the same play, but with not the same effectiveness compared to others. So that would be a good example of where you would go through the data here and try and find a way or really recognize something on those outliers. A similar thing here. Um, if it wasn't for, if it was still last year, looking at plays as far as the wide receivers go, comparing someone like Tyreek Hill to some of the other downfield threats and just realizing how quick he is compared to others and how quickly he gets away from others once he catches the ball because he's known for his really fast acceleration once he gets the ball. So whether it's at the snap and just beating people purely off the line, or he gets the ball and continues to make a player miss by just outspeeding them. So the idea here is they provided the data here. These are the data sets you see here on the left. They provided all these. So the data here, games are the teams that are playing in each data. It mentions the season, the week in terms of the schedule, the date, the time played, and then the teams and the scores of the games. Then there is play data, which is almost like a combo table. You have the game ID, but you also have an ID for each of the plays. It will tell you information about where it is in the game, the down and distance, or what down it is in terms of first through fourth down, how many yards to go to get another first down, who has the team, so like the offensive and defensive teams, where it is on the field, where it is in terms of the clock in the game, and then like score information, so you understand a little bit more in terms of the context, right? Generally speaking, if a team is down by 2 or more scores, they will typically be more pass heavy in an attempt to quickly catch up in terms of the score, right? And we can try and go through the data and see if that's actually happening. Um, it includes things like the win probability. So this would be a good way to see if you can just, when we go through some of the introductory analysis here, seeing what plays cause the biggest shift in win probability through here, the expected points that the play generates. This is a way to say in a certain situation, this play usually will generate some amount of points. You can see like field goal kicks within certain ranges. It should be 3 and then a factor down based on how likely it is for them to actually score based on the distance of the kick. There will be information, it says, as far as the formation and alignments go. So that's just giving you an idea of the formation that the offense has and how they're laid out before the distance has. And then a bunch of other information specifically related to the play, the time to throw, time to sack, things along that. And then there's also the individual player data. So that's the players here. You'll see basically it's sorry, it's a table with the individual player ID and then all their information. We talked here about what are the plays here, so the ID and the play ID. What else is here in the list? There is a player play data. That's this one. Let's go here. So this will talk about not just for the individual play, but also, sorry, for the game and the play and the ID of the player, or what impact they had specifically on that given play. And then, like I said, this is the list of all the individual plays. So it's going to link out what is the game ID, what is the game ID, what is the actual play that was involved, and then a description of the play. So you're going to have to take this, you can see here, description, and break it down into its pieces. Right, like you can see, okay, it's a shotgun formation, pass, all of that. Then there is the individual tracking data. Each of these files is almost a gigabyte in size, so it will take a moment for the preview of these to load. But let me see if they laid out what it is. Yeah, so for each play in a game, the player information and then where they were on the field. So if a player moved where they were, so you can see, for example, in this play, in the 40 seconds before the snap, well, I guess this is longer than 40 seconds. These are the frames. Okay, the individual frames of when this is happening, and then their location on the field. So are they moving around once they've got into the set position? And then you can see here, this is when the snap had happened, and then everything else is marked afterwards as for snap. So then where did he move on the field on a given play? And then they have these for the 9 weeks that are here so far. So we'll go up here a little more and we can see what information. So when this actually happened, the team that they're playing for, and then the direction of the play, their location on the field. X and Y is the axis of the field. So X can go from anywhere from 0 to 120, and then the Y goes from 0 to 53. So this is likely in the huddle behind the play, and then breaking out to where they move in the snap. And then you can see their speed and acceleration. And then the distance is how far they had moved from their previous spot. Player orientation, here is a 360 degrees, and then where they're moving, and then individual information about the field here. So bring this over here real quick. This should show more of the information about the field. So you can see the X value. There are 120 yards going across the field. That is because each end zone is 10 yards. And so you're going to have to take this out of the data set so you know where they are in terms of the actual field, and then figuring out where they are um, going left to right. So what does this mean? Well, the home team will be the 0 to 10 end zone. Then the visitor will be the 110 to 20 here, and figuring out where exactly those go here. They do have some introductory EDA here in the file here, but then you have to download them. So go through each one of these. It's about 8 gigs to actually download each file individually. You can download all and get them in a zip, which for me was about 1.2 gigabytes. So not too large to get all the data in here, but then when you're working through them, I do expect it to take a little bit of time to load the tracking data for week 1 and week 2, just because there are so many rows here in each of these CSV files. So you can see if you actually be careful actually loading these into Excel, because there's far too many rows for it to actually display. So if you open in Excel, do not save it before you close it, or else you will get cut off for rows, because week 1 here, there's over 7 million. And then if I remember correctly, the Excel cutoff is around the 1 million row mark. So it will throw you an error when you're trying to load this. Not to mention it will take a long time for those to actually display. So just a kind of warning before we get started here. So when you're going through these, then yeah. The idea here is that I'm just making a general notebook, so that way we can go through and load each of the files, and we can display things pretty quickly. So that way we are seeing things pretty quickly. So let's go here. Where is, okay. So quickest way would be to use pandas to load each of the CSVs. So just go pandas read CSV, oops, and I give each of these a set, right? So I'm just going to call them, each of them by their file names. We're going to go through and just keep doing this. So player, play. I'm just going to make a second one for the idea here is just because depending on the size of your computer or the instance that you're running, you may not be able to load all these individually into a single memory read. And what I want to see here, I want to do the first couple weeks for what we're looking at, just to make sure the data is like in the forms that we had expected here. Oh, what is this? Doing that as my time. I didn't have this installed into Jupyter. Installed with VS Code. Going through and putting those in. Don't tell me none of these are installed here. All right. Yeah, it's already installed. Okay. What? No, it's running now. Okay. So it's just that it was detecting a new Python version and tried to default to the 3.11 when I selected that, but 3.9 is the one I had used before that. 3.11 is the one I have installed on the Ubuntu instance here, which I was using for my other project, which was the reinforcement learning for Pokemon. So that's why it happened. And you can see here, part of what's going to take a little bit of time for all this is just because these are larger data sets. So if I was kind of using the first couple instead of trying to read them all in, hopefully this doesn't take too long. Part of the, I guess, downside of doing this live is you have no idea what it's actually going to look like. I had only done 4 just in part because I have limitations on this computer. We've only got 16 gigs of total RAM, and the GPU is 8. So hoping that I don't run into issues. Okay, there we go. But it does take time to actually go through and load those. So then got that. Do this here. This at the level on its own. Import B. Lib. We have pandas. See, it should get us at least base there. You will see things pop up. That is the local instance of CodeGemma that I have running. It kind of just runs in the background as a code assistant tool. I have a video there on how to get that set up in your Visual Studio. That way you'll see here, like when I type in a new row, if you hit Control I, you can tell it to generate code based on what you had typed there. So with all that, let's start here. Checking all data. Games. You can see here how it did it quickly. Great. Nothing in games is null. we're just going to go through these kind of one by one. I guess that makes sense because not every single player is going to be involved in those, so I think that is fine. There, it was more important that none of these were null. As far as the player information, some of them don't have birth dates. That is fine. Well, plays. Yard line side. Fine. May not always have the formation for a play. Okay, makes sense. Pass result and length. It makes sense that these are nulls. It may not always be a pass, right? Or a pass of any distance. We have those, and then pass option should always be 1 or 0. And then the coverage type. Let me go back to their file, to the data, and let's see base file. Yes, there are a ton of information in here. Man zone. Gotcha. So I guess on special teams plays, these wouldn't have anything in there, which makes sense to me. Second week one, it's going to take a moment to go through. Interesting that so many of the events in this is null. Let's see. Act play details, including movement of ball, snap, pass, release, catch, tackle, etc. Okay. So it says here the NFL ID and the jersey number correspond to an individual player identification. If it's NA, that is the ball moving on the play, and then that makes sense. So the ball won't have a player orientation or player motion. So that explains why for those rows that there is just nothing there. And then the events, it's actually important that rows are null for those. It's marked as tag, key play details when the ball is snapped, pass, release, catch, tackle, etc. Okay. That makes sense to me. Generally speaking, we don't see a lot of missing data in here. And then the data that is missing is intentional. So let's just write the notes for that. ID, jersey number. Oh, for the ball locations, the ball locations / rows on the play. There, and that makes sense. So generally speaking, we don't see much as far as missing data goes. So it's a really clean data set. So once you're kind of working with data in general, there's already been a ton of work put into making sure that these are clean and you can generally be usable and reliable. A lot of the work that I do most of the time, it's just cleaning and understanding your data. We're doing the understanding part by going through and looking at some of this, but it's good to see the work that's gone in here to make sure that you already got a really useful data set here. So we do have good data, generally speaking, in the data sets that we're seeing here. Interesting. I don't think I would remove any rows here based on what I had seen. Right? I don't think back to place. I think that would be one. Yeah, I don't know that would be worthwhile to really remove data here for these. So next step here, let's go through look a little bit more at the plays. Data set here, I'm just going to open it so we can see the table. Quarter down, yards to go, that's gained. Maybe it's easier for me to pull up the table here. Let's go. I just do this. It should tell me like the average pass length is about 7 yards. Cool. And then rush. I don't know rush length. What is the rush version of this? Am I just missing it in the list here? Let's see. If you pass length, row. I switch this to just yards gained. So that includes both the rush, but why do I see? Can I say the The average penalty resulted in only 1.3 yards. That's interesting. That's probably getting decreased by declining penalties? Or is it just a mean because there's so many zeros that it's being thrown out? Yes. Interesting. So in the player play, it has the rushing yards. It also has receiving yards. So player play. Rushing yards. And do the same thing here. What do they call receiving yards? It's definitely including zeros in those. We want to leave those out when we're calculating this overall expectation. Let's see. There's penalty. There's yards gained after catch. That sounds okay. There are so many different ways you can go about this in terms of like what you want to look at. So that's why they probably tell you to narrow it down a bit. Right? If I look at play, information here. Yeah, so I think the next thing to do here is to come up with a strategy for how we want to look at the data. A few things I see here. You can look at individual players who get, well, first we want to take out the zeros like on the rushing plays to make sure we're doing a valid comparison. And then looking at, let's say, players who have more rushing yards than average by how much. Um, even the likelihood that they have a rush that is an outlier would be something. So I can imagine, there's some design plays for receivers to kind of get an end around where they come moving across the formation, right? And then the idea there is that they can be fast enough to beat the defenders to the edge, and then hopefully cut up field and make good yardage. Um, Looking at even just some of the running backs who would generate more yards than others on their runs. I imagine, for example, this year, like Derrick Henry would be a player, would be an outlier there. Saquon Barkley generating more rush yards than the average, and then similar things for like receivers, right? Idea here is just kind of better understand the data and then start to work on once we've got like those outliers to look for, who to target, let's say on specific for our specific analysis. So let's say like I'm an Eagles fan. I wanted to see how well Barkley performs compared to others in terms of rushing. We can go into that, maybe even like by formation, what you can expect in terms of his yardage, right? Pre-snap versus post-snap, and then include like, is there motion? Do they audible or change their formation into a more potent play? That would be a way you can kind of look generally, or even at a team level. So let's just say the quarterback gets there, changes their plan, right? Like Peyton Manning was famous for this. Is he would look at a defense, he would make adjustments, not necessarily to the formation, but to the play call to counteract what he saw from the defense. So do we still see that in? Do we see that in data here for certain players where they're considerably above their normal output on plays like those? We get an idea of like who's best at making adjustments to what they see. An easy way to do this would be looking at the yards after the catch for players. So the so if you have a receiver that's really good at taking that first hit and breaking it and then turning it into a bigger play, I can imagine some of the bigger receivers would be good at that. Same thing for some of the running backs, where you're trying to kind of look for some of these outliers, not or in terms of the individual players. You can also look at outliers in terms of plays, where it's not just it's the expected outcome of the play versus what typically had happened, right? So we can define this as like explosiveness is what you'll hear a lot on TVs, where this team kind of wears you down until you see a big explosive play. So you have typically Joe Flacco was famous for this, where uh, they would get small play, and then all of a sudden a big chunk play. And you only need a couple of those to change the outcome of the game. I mean, Flacco's still playing this year, but the good examples of those where you have almost a large outlier pretty frequently for a team, that hopefully we can see that in the data here. So what I want to do is for the next stream in this, go through and come up with the ways to remove zeros from the data here in terms of our analysis. Maybe look at specific pass plays that had large returns, and then try to figure out were those large outliers, maybe using they had the expected points per play in here. So can we look at the data that way and see there? But that there's a bunch of things here spitballing. The good thing here is we proved out data set's very clean to start with. It will take a little bit of time if you're downloading the data and pulling it into your instance, but there's a lot of different ways to go through that. So I want to spend the next session just doing more of the data discovery side of things, looking at specific cases here where we're going to look for outliers in the data. And then to me, that's usually the most interesting area to look at in this, is like who is generating the most outlier types of plays. And then from there, decide to go into, okay, maybe a specific player or maybe a team is really good at generating those types of plays. And maybe there's a team that is the opposite. For whatever reason, they are not generating those same types of plays, where they have kind of those outliers. Or maybe, because I know people are saying like scoring is down this year, especially in those early weeks across the NFL. Is there something that the defenses were doing to counteract that? Or was it just the players weren't making as many big backbreaking plays as they were before? So I know this section, we didn't do a whole lot as far as the code goes. We're really, you don't, in terms of projects like these, you don't just want to dive in and start coding. You really want to get to understand your data set, as well as understand like what is our objective going to be here. So that way you can dive in uh, once you've understood the data better to the specific areas that you're looking. So what I'm going to do is I'm going to wrap this up here. And then, like I said, next time come back with maybe a list of things to work through so we can approach those in these hour sessions to get an idea and do a breakdown. Again, I don't think you have to do anything overly complex here. In these early stages, the idea here is understand the data set, understand what it is you're looking for, and then start to work towards that with the data that we're given. One of the key things here on this challenge is that any data that you're using has to be free and publicly available. So we have the data here that they provided to us on the individual plays. I want to really work with these provided information and then see if there's anything we can find here that would be interesting. So if you're seeing this video, please feel free to leave a comment on anything particular that you think would be interesting, and we can dive into those. In the meantime, I'm going to also continue looking through the data a little bit, find a way to get a better idea of who some of these outliers are in terms of individual plays, whether it's individuals or teams, and come back, I guess it'll be later this week, with a plan of attack on that, and then figuring out how we want to look at the data here. So for those of you who are seeing this and are curious at a later point in time, please feel free to leave a comment. Looks like there's a comment here. I understand the focus this year is on pre-snap data. How will you be focusing on that? But I think as far as the pre-snap data is, you want to compare what happens before the snap and what happens after it. So one way you could do this is to look at some of the motion that's happening in the data set here. So like we were looking at the tracking data here, just to kind of show some of this is you'll see it has everything. So when the players are in the huddle versus when they come out in the field, I would be even here looking for players who have a large amount uh, of movement here, not necessarily in the X direction, but in the Y direction. So if you wanted to look at players who were kind of moving across the field all of a sudden, or if they were pretty stable in their position, but then before the snap, there was a sudden change. So that would indicate a change in the formation that you're seeing. That would be a way to look at what you're seeing there before and then after it. So this would give you an idea of players or teams who are adjusting well to what they see from the defense. So I would expect some more experienced quarterbacks would start to show up here. You would see the individual players moving, but it would be the quarterback who would be creating those changes. The idea then from that is that they were making an adjustment to the play, and you're hoping then that you see a better outcome in terms of what would have happened before versus what happens afterwards. We don't have the individual play calls for it in terms of like what the coach had actually called in versus the actual outcome of the play, but we can see with adjustments like that that they made a change in the play. There is also where's the data set here? There was, yeah, there is a flag for in motion at ball snap. So if the player was already moving, then it will be flagged here. And then there's also motion or shift since line set. So these are a bunch of flags that we can use here. Which data set? This is in the player play data table. So we can get an idea of the players that had made some type of movement or adjustment. And then like there's so much here in the data for ways to go with this. Um, that I want to focus these first couple sessions on understanding data first and then deciding how to go with it. So those are a few ideas on what you could do like pre-snap versus post-snap. You could also look at this pre-snap like formation wise. Um, did certain teams do well or do better with certain formations than others? Historically, the Patriots were a great team with Tom Brady at the quarterback that were great in the 12 formation, which is one running back and two tight ends. And they would typically, or they would not typically, they would outperform other teams in that formation. Um, I think it was 2 years ago when Philly was a run heavy team. They were also very similar, where in that 12 formation, which is one running back and two tight ends, they would have better performance in those plays versus others. So those are a couple ideas for it. What I'm focusing on, at least at the beginning of the series, is just looking at the data across groups as a whole to try and break it down. So that's also an idea, is just come up with how do we splice this out to look at individual teams here. So we can do some slicing with the data set in pandas and see maybe there's a certain team that you're interested in, see how well they're doing with certain formations pre and post snap, right? So then the expectation on those plays, they should outperform those expectations that are there in the data set. So I think there was a points expected per play, and then I don't know if they have anything as far as like yards expected per play, but that would be something you would try and generate. I know those exist in some of the other data sets out there, and maybe that's something that we can put together as well, is what is the expectation given the formation and the play style of what the outcome is, and then look at adjustments between those individual teams once you've established that whatever that baseline is, to understand how well certain teams use certain play types. So hopefully that helped you answer the question on different ways that you could go with the data set through here and understand that better. Like I said, I'll come back next time with a plan of attack, and we'll get some of those metrics put together and create some of those comparisons. So if anybody else has any, or anybody else is seeing this at a later point in time, feel free to leave comments on the video, and I'll work through. We'll be going again on this, I would say, well, I'm usually off on Wednesdays from streaming. Thursday is usually when I do the reinforcement learning project. So I'll probably come back around this on Friday.